Welcome to our channel Quaint Cosmos. In electrical circuits, what happens? The applied EMF means electromagnetic force that causes current to flow, means electric charges to flow through the circuit. So that happens in case of electrical circuits, and in case of magnetic circuits, what are the key elements? Key elements are magnetomotive force or MMF, magnetic flux and reluctance. So in electrical circuits, resistance is there, and in case of magnetic circuits, reluctance is there. Okay, and magnetomotive force same as electromotive force. Okay, that means in case of magnetic circuits, that magnetomotive force that actually allows the magnetic flux to flow through the material like ferrite, iron, etc. Anyway, so here in this video, the topic of discussion is actually inductance. So consider a solenoid. You can see the image. Consider a solenoid. Along the axis of the solenoid, the vector B is shown, is displayed. Okay, vector B represents magnetic flux. That is the direction of the magnetic flux. So that is along the axis of the solenoid, and you can see in the image. You can see that the current vector is perpendicular to that direction. That means current vector is perpendicular to the direction of the axis of the solenoid. Why this happens? Why this is perpendicular? Because current passes through the coils. So you can see number of turns are there. So if you consider only one turn, so that makes a plane, and the current flows through the circuit or through the wire. That means current is always tangential at any point of any coil, tangential, and also the current lies, means the current vector lies in the plane of the coil. That's why you can see in the image that a current vector is perpendicular to the direction of the magnetic flux vector. So you can see here that induced EMF is equal to what? That is a negative sign of N phi by I, where N is a number of turns, phi is magnetic flux, and I is the current. So that way inductance is actually defined, not EMF, sorry. Inductance is defined that way, N phi by I. So this term N phi, the product of N and phi, this is called magnetic flux linkage. That means inductance is defined as ratio of magnetic flux linkage and current passing through it. Again, one more mathematical expression is there for the inductance, and that is given by E is equal to minus L di dt, where I is the current, T is the time, E is the induced EMF. Okay, and negative sign is present in the expression for EMF because of Lenz law. So what happens actually in case of this inductance? So inductance means this is present in case of an inductor. And inductors are used in so many cases, such as transformers, motors, generators. Okay, many where these inductors are used. Anyway, I was talking about only inductance. So inductance is the property of an inductor. What happens actually if there is a changing electric field? Okay, I am not talking about constant electric field. If there is a changing electric field, then what happens actually, electric, when say for example current is flowing through a wire, so in that case around the wire magnetic field is created. But if you change the current, such as for alternating current. Even for DC current, you can change the current. And if for alternating current, it changes continuously. That is known to you. So if you change the current, so there will be a change in the magnetic flux also, magnetic field also. Okay. So since there is a change in the magnetic field around the wire, so that change in magnetic field causes an induced EMF, and that opposes the reason for which there was a change in the current. And this is Lenz law, that is known to you. Okay. So I was talking about what, this phenomenon I was talking about this phenomenon. So that's why negative sign is there. The reason of negative sign in the expression is due to that fact. And here, from here also L can be defined. You can see that induced EMF is equal to minus L di dt. Therefore, L is equal to what? It is equal to induced EMF into dt di, means dt by di. Okay, and unit of inductance is known as Henry. So therefore, from here you can say easily that 1 Henry is equal to 1 volt second per ampere. 1 Henry is equal to 1 volt second per ampere, and the symbol which is used for denoting Henry is capital H. It is according to the name of the scientist, Henry. Anyway, so what? That means here the inductance in any magnetic circuit works like a guardian. Guardian who is very stubborn. If there is any change, then that guardian tries to stop that change. So similarly, in case of magnetic circuits, whenever there is a change in the current or whenever there is a change in the electric field, immediately an EMF is induced in that coil or in that electric circuit, which actually opposes that change, and that property is known as inductance. Okay, so many reasons are there for which inductance may increase or decrease. Suppose in the circuit air gaps are present. If air gaps are present, in that case reluctance increases. That means in that case inductance decreases. That means in case of transformers, air gaps are not desirable if it is not made for specific purposes. In general, in transformers, air gaps are not allowed, because air gaps in any circuit increase the reluctance and thereby decrease the inductance. Okay, again material, if the permeability of the material is more, in that case inductance will be more. Again, if number of turns is more, in that case inductance is more. Just by analyzing the mathematical expressions for inductance, you can say all these things. Okay, and if you talk about applications, so many things are there where these are applied. In case of magnetic sensors also, this is applied. Just by detecting magnetic flux, the sensors work. Again, in case of, I have already mentioned, generators, transformers, motors. Okay, mutual inductance concept is there. Actually, two types of inductance is there: mutual inductance and self-inductance. Okay, self-inductance means whenever you are using a wire, suppose a simple wire you are using, and current is flowing through that wire, and if there is a change in the current flowing through that wire, so in that case inductance is created, and that inductance is called self-inductance. Again, if you talk about mutual inductance, then that thing you will find in case of transformers. You know, in transformers, two types of coils are there. Primary coils are there, again, secondary coils are there. And in that case, the energy is transferred by the help of mutual inductance. Anyway, so this was all about today's topic, inductance. Okay, so if you found this video informative, please like, share and subscribe to our channel. And this is the end of this video. Thank you for watching this video.